All right, guys, this is the division law of exponents. I am going to try my best. I'm currently stuck in the car. Last day of August at a soccer practice. So let's see what I can do on the car seat here. So division law of exponents. Oh, it's already not working. What you're going to see is when you have an item that has the same base, but it's in a division problem, what you are allowed to do is subtract top minus bottom exponent. This is okay. I like to follow these two questions. If you're going to cancel them out, so cancel out your exponents, I want to know two questions. How many are left? And second question, which a lot of people forget to do, is where? Where are those extras left? All right, and I'm going to show you why this works. So if I give you the example, and I'll just keep using these m's here. If I have m to the 4 over m to the 3, if I had all the time in the world to write this out in expanded form, I would have 4 m's on the top and 3 m's on the bottom. Now what happens when you have the same thing on top is the same thing on the bottom? Well, the same thing as before. If you have like a 4 over 4, what they do is they cancel out and basically just give you a 1, which in this case, a times 1 is not going to mean anything mathematically. So what you're going to do is cross off 1 with the top, 1 on the bottom, 1 with the top, 1 on the bottom, 1 with the top, 1 on the bottom. I can see that there's 1 extra left over, and it just so happens to be left over on the top of my fraction. If you have something left over on the top of your fraction, you just write m. It's kind of like saying 4 over 1. Nobody says that. They just say 4. So if there's nothing left on the bottom of your fraction, you're just going to say what's left over on the top. All right? So if I use this, how many are left and where there's 4 on top, 3 on the bottom, 3 of these are going to cancel. There's 1 extra. The top has 1 extra, and where is it? It's on the top of my fraction. All right? So we're going to do a couple of these. So this is the reason why we're not going to write this out, because sometimes you're going to have like m to the 12. You don't have time to write that out, and you're going to make a mistake. So we're just going to use the questions, how many are left and where. So if I have x to the 3rd over x to the 5th, I'm allowed to cancel some of them out. I'm going to ask myself, how many are left? Well, there are 2 extras on the bottom. Look, if I do 3 and 5, if I subtract them, there's 2 left over, and they happen to be left over on the bottom. So I have to write them on the bottom. You need to put a placeholder 1 on the top. If there's nothing left on the top, I need the 1. This is the only time you're going to notice that a 1 is important, if there's nothing left on the top of my fraction. All right, next example. I have a to the 7 over a to the 4. So let's see, if I subtract them, I have 3 extras, and where are they? They're on the top. I have more a's on the top than I do on the bottom, so I'm going to put them on the top. And if they're on the top of my fraction, again, you don't need the bottom. The only time you need a 1 is if there's nothing left over on the top. So let's do another example. I'm going to combine. I'm going to say x to the 6, y, and then I'm going to say x to the 5th, y to the 7th. Sorry, that 7 looks wacky. So I'm going to notice that I'm actually missing an exponent, which if I look at my order of operations, I need to do placeholders, right? So we're going to put a 1 exponent on top of that y. And that's going to help me understand the problem better. So look at the x's. The x's have nothing to do with the y's, so ignore the y's for a second. And pretend like I gave you just the x's. So I'm going to ask myself, if I subtract, how many extras are there? There's 1 left over. And where are they left? Well, there's more on the top. So this 1 is left over on the top of my fraction. Now let's look at these y's. I have 1 y on top, 7 y's on the bottom. If you subtract, that's a difference of 6. And I have to put them on the bottom because there are more y's, which means when I cancel them out, I'm going to be left over with that on the bottom, the y's on the bottom. Now this is a good answer. The only way to make it a little bit better is any extra ones that you have in the problem, get rid of them. The only time you need a 1 is if it's the only thing on the top of the fraction. So this x is here, which means I didn't need the 1. The reason why I needed this 1 is because there was nothing left on the top of that fraction because I got rid of all my x's up there. All right, so next example. All right, first thing I'm going to do is check for placeholders. I need a 1 exponent right there, so we put it there. Next thing I'm going to do is check to see if we have any parentheses, right? If I have anything, parentheses, I could check to see if I can clean the inside or do exponents. Because I don't have parentheses, I'm actually skipping both of those steps. My next, zeros and negatives, we haven't talked about yet. So smushing, can I put anything on the top with the top? No, these 3 cannot go together. Anything bottom and bottom smush? No. So the last thing I'm going to do is divide, which is canceling. That's the skill for this video. So I'm going to look at the x's. I have 13 on the top, 1 on the bottom. If I subtract, I have 12 extras, and where are they? They're on the top of my fraction. Let's look at these y's. I have 5 on top, 5 on bottom. If I subtract, I have no y's left. Do not put y to the 0 power. That makes no sense. That's like saying you have $0. You just don't say anything. All right? So we're going to just cross them out. No y's. Let's look at the z's. I have 4 on top, 8 on the bottom. So that means I have, if I subtract, 4 extra, and I have to put them on the bottom of my fraction. The only thing I would do is just check to see if you have any extra 1s hanging out, and we don't here, so we are good to go. Now, on the next example, I'm going to add coefficients. Remember, coefficients are big numbers up front. And I want to stress that the law that I just taught you or went over in this video is an exponent law, which means you cannot use that law on big numbers. So I am going to do a 2x to the 3rd, y to the 4th over a 16x, y to the 5th. Okay. First thing I'm going to do is exponents. Placeholders. Placeholder exponents, sorry. Just give everything a placeholder exponent. It's not going to hurt the problem if it has a 1 exponent, all right? It's like saying 1x. It doesn't hurt the problem, it's just extra. All right, so next, I'm going to see if I have any parentheses. Do we have any parentheses? No, so we're skipping parentheses and exponents because you can't do this one without having a parenthesis. There are no 0 exponents and no negative exponents, so we're going to go with smushing. Can I put things together on the top of my fraction? No. What about the bottom of my fraction? No. The last thing I'm going to do is cancel and divide top with bottom. So I'm going to start with what we already know. Let's look at the x's. I have 3 on top, 1 on the bottom. When I subtract, I have 2 extras, and where? There are extras on the top. Remember, you're always leaving it where the exponent is bigger. Then I'm looking at the y's. I have 4 on the top, 5 on the bottom. If I subtract, there's 1 extra, and where is it? It's on the top or the bottom of the fraction. So 1 extra. Now, please do not subtract the big numbers. 2 over 16 has never been, I'm afraid some of you guys are going to do 1/14. You're going to subtract the numbers. 2/16 does not equal 1/14. It never has, it never will. Think about this. This is what we would do in a recall box. If I have 2/16 and I gave that to you, and you know the directions would be to reduce that, this would turn into 1/8. 1/8. 1 on top, 8 on the bottom. Now this is a good answer. This is a good answer. You're going to get just a little small smile from me from that. I want to make it a great answer, and the way I do that is by getting rid of any extra ones that we don't need. Remember, the only time I need a 1 is if there's nothing left on the top of my fraction. So I can get rid of this because I have an x squared on the top of my fraction, and I can get rid of this. The only time I need to see a 1 is if there's nothing left on the top of my fraction, which I'll show you in the next example, okay? All right, so let's do another example. Move that over. Let's do, all right, placeholder exponents. Let's put them on there, even though you're probably not going to use them on the big number. We usually don't use it. There are situations where we do. Next, do I have any parentheses? No, so I'm skipping parentheses and exponents. We haven't talked about zero exponents or negative exponents. Smush, multiplication. Can anything on top go together? No. Can anything on the bottom go together? No. So now we're on divide. So I'm going to do the x's first. I have 7 on top, 8 on the bottom. When I subtract, there's 1 extra. And where on the bottom? 1 extra on the bottom. Whoops. Let's look at these y's. I have 3 on top, 3 on the bottom. How many are left? Well, subtract. There's no y's left. No y's. Please do not write 0y. And let's do a recall box with our fraction. I have a 3/6. 3/6 has never ever given me a 1/3. Don't subtract these. We're going to reduce. It gives me a 1/2. 1/2. All right, I forgot to make my great smile over here. So this is a good answer. Let's see if we can make it a great answer by getting rid of any extra 1. So ask yourself, do I need that 1 on the top of the fraction? And the answer is yes, because there's nothing else up there. You can't have a fraction bar with nothing on top. And then this is extra. We don't need that. 2x. Think about it. My handwriting's getting a little sloppy. If you just had a fraction bar and a 2x on the bottom, that's like me saying divide by 8. And you're like, divide what by 8? I don't know. You have to have something on the top of a fraction bar because it's a division problem. You can't just say divide by 2x. You have to say 1 divided by 2x, which is why we need that placeholder there. All right. Let's do one more, and then we'll be done with our division mini lesson. So let's say I have 3x to the third, x, y to the fifth, z squared, all over 9x to the 8th, y squared, y squared. All right, so let's take a look at this. I have some things that I need to do. First thing I'm going to do is placeholders. So anything that doesn't have an exponent, give it an exponent 1. We got it here, here, and here. Next thing I'm going to do is check for parentheses. Do you have any parentheses? No, so we're skipping P and E. Parentheses and exponents. We're not doing the red because we're not there yet. Negative and 0 exponent. So I'm on M. Can I smush anything on the top of my fraction? So let's check out the top of this fraction. Is there anything together that I can do? Yeah, look at those x's. There are too many x's up top. So we're going to put them together. That's smushing. Let's look at the bottom. Is there anything on the bottom? Yes, these y's need to be together. So on the top, I have 3 to the first. I have 3 and 1, they're not division. Smushing means adding your exponents. I have 3 x's and 1 x. That's 4 x's. These y's and these z's don't change because they didn't have any friends. The 9 goes on the bottom. I have an x to the 8. Nobody stays the same. I have 2 y's and 2 y's. They're on the same level. When they're on the same level, you add them. Do not subtract. Subtracting is the last thing we do. It's the division part. Division is canceling or subtracting your exponents. Multiplication is adding or smushing your exponents. So now we're on division. So let's go ahead and simplify x to the 4th. How many x's are left? There's 4 extra x's, and they're extra on the bottom. Let's check out these y's. We have 5 on the top, 4 on the bottom. How many extras are there when I subtract? There's 1 extra, and it just so happens to be on the top of my fraction. And that z didn't change because it didn't have anyone to change with. Do your recall box. 3 over 9. 3 over 9. Let's reduce this. 3/9 has always been 1/3. 1 is on the top of your fraction. 3 is on the bottom of your fraction. This is a good answer. Now to go from a good to a great, I'm going to get rid of any extra ones that I do not need. Do I need this 1? Well, the only time I need a 1 is if there's nothing else on the top, and I have other things up here. So this 1 can go away. Any exponent ones are not needed because y is the same thing as y to the 1. It's the same thing like 1x is x. All right. So let's take a look at our next thing. The z is good to go. The 3 is good to go. And the x to the 4th doesn't have any extra ones. So this is the best. This is the great answer. Difference between good and great. All right, so that is your review mini lesson on division, law of exponents.